So I got another Physics 2 question from a student. I think they might be more or less in the same course. So I'm going to go over some more Physics 2 stuff. So this is regarding E field and electrical potential. And I want to start by just reminding us that our E field, which is a vector, our E field is equal to K, which is a constant, Q, our charge, divided by the distance where we're looking squared. And this R hat indicates that it has some sort of direction. That's a unit vector. There's also E potential. And we usually denote that as V, and it looks very similar. It's K, Q, but it's just over R, and it's a scalar. It's not a vector. So there's no unit vector associated with it. They look very, very similar, and I think you'll find that if you take a derivative of your E field, so R is a function, right? R is the function you take the derivative with respect to. However, because we'll be dealing with Cartesian coordinates, you'll deal with something called partial derivatives. And if you aren't aware of this, I could maybe make a video talking a little bit more about it. But the E field is equal to negative the gradient of your potential, where the gradient is just partial with respect to x, partial with respect to y, partial with respect to z. So that's all that's having us do. I'm assuming you're familiar with this. If you're not, then that's something maybe to go over. I could potentially make a video on it. But the important thing to know is that this is how the E field and your potential is related. Now, in the problem that was given, we were told that your change in potential is ax squared y cubed plus bx z cubed minus cxy z squared. And they want us to find the electric field in the E direction at a certain point. So we know how they're related. We just have to take a bunch of partial derivatives. So if we were to take the partial derivative of this stuff I put in parentheses with respect to x, you'll get 2ax y cubed plus bz cubed minus cy z squared. That's your x. Now we'll do the same thing with y. You'll get 3ax squared y squared. There's no y in the second term, so that'll go to 0. Minus cxz squared. That's your y component. And then your z component will do the same thing. So there's no z component for our first term. So you'll get 3bx z squared minus 2cxyz. I just wrote it like this so we can hopefully see this is the x component, this is the y component, and this is the z component. Okay, and then one last thing we have to do real quick is let's not forget that this is negative. So that's just going to change the signs. This should be a negative, positive, negative, positive, positive, negative. There we go. Okay, so the z component is just minus 3b x z squared plus 2c x y z. This is your E field and the Z direction. So this is E field and the Z direction. And they give us what A, B, and C are equal to. And then it says, it wants to know at the point, so at point, .30 meters, 4.00 meters, and 2.90 meters. And this is just like your X, your Y, and your Z. So you can plug those in for X, Y, and Z, and then they give you A, B, and C. All you have to do is plug those numbers in, and you'll get the E field and the Z direction. So hopefully that makes a little bit of sense, and that helps some of you guys out. And perfect, my pen is